So, OLTP systems history. So anything that was happening, right? I would say way back ago. When we were not even IT engineers. Things were happening on papers. People were writing down it on papers, and they were managing everything from the perspective of uh, files and systems. So when everything moved to databases, they thought like we how to track this, okay, how to track everything which is happening. So examples of OLTP systems came from business events. Okay, a person logging in is a transaction. A person hitting on buy now is a transaction. A person entering is information in the form and clicking submit is a transaction. What is not a transaction? Okay, you have opened a page. Now you are filling the details. Okay, your first name, your last name. Until and unless you enter the submit button, it will not create a transaction. Okay, so coming to that page was a transaction. Being on that page is a session for a website, not a transaction. But you are entering details. But the moment you press submit, it will again create a transaction. So everything that was attached to a commercial thing, previously, that okay, I did a transaction, it was a debit or a credit. So that way people were seeing it, and that's only when way back, maybe in early 90s or 2000, things were there. But as in when the things have evolved, yeah, right, social media is there, everything is using databases, right? And they and everybody, right, you want to see your stuff at the moment you enter it. Okay, so you entered a post on a LinkedIn, you want to see right away, it gives you view post, okay, so that you can see it. You shared a post on Facebook or Instagram, you want to see yourself right at that moment. You don't want to wait for even that something to happen. I will not name that something, which we all know, because we are data engineers. We all know what happens in between and then it goes to another system. But you want to wait for a batch processing to see your comments? No, you don't want to do that. You you are thinking, I just entered it, why should I not see that? Okay, I just entered the information, please show me that information what I have entered it, whether it is your address anywhere, whether it is your uh, you know comment on a LinkedIn post, you want to see that. So all that things involve one thing, which is fast writes and reads. Okay, you entered, you want to see it at the moment you entered it, within 2 seconds you want to see it. Otherwise you will just go away from that website or app. So transaction processing just means allowing clients to make low latency reads and writes, as opposed to batch processing jobs which only run periodically. Okay, right? So batch jobs run only periodically. Okay, so we are not going to talk about that. This is OLTP topic. So I'll stick to low latency reads and write. So I'll want you to focus on this perspective which I am talking about right now during this session. Okay, just focus on this point. Okay, during the full session, which is this. Low latency reads and writes is the only thing. I would not say is the only thing. I would say is the most important thing that we want from an OLTP system. We pushed it, we want to see it, that's it, show me. Okay. Now, what happened is that everything was tied to a transaction. Why? Okay. Because we thought it is a commercial transaction, let's name it as OLTP. Online because you were online, and transactional because you are doing some transaction. So everything that was tied to a transaction was called an OLTP system. So that's how the name came up. And application typically looks up with a small number of records. So this example I'm giving you, wherein people actually enter their information and they want to see their data first, okay, their post. So there is a username somewhere, right? Your LinkedIn ID or maybe your Instagram ID, your Facebook ID, something they already know, which they have taken it as a first thing when they were registering you, right? So they know who has logged in. And then on top of that, there are a lot of web development happened which they can do, but to persist it, they used OLTP. Okay, so they cannot, just vanish your posts and something. So they had to save that thing by some key, and it was index. Okay, so this was a basic idea of OLTP. So I just wanted to give a brief about OLTP and OLAP again, and we have already talked about this. Uh, that OLTP is something which is happening right now, right in the moment which you want to see it, and you want to go via low latency reads and write. Okay, you don't want to wait for it. So main differentiation that I have already told is the read and write pattern. Okay, primarily used if we see end customers, right? Web applications. Uh, what data represents latest state of the data. Okay, it's not that we keep on appending it. Okay, those things we will talk later when we go through another system which fetches the history and it goes to another system which is OLAP. But to OLTP, it will not. It maybe it shows you the history of last, let's say, last 30 days, but that is all web development on top of that. Okay, but OLTPs were basically built to show you the current state. Okay, even if you go to any, okay, I'll tell you. Let's say you have HDFC or ICICI bank account, right? If you go to statement, it will first show you last 10 days, 30 days, maybe 6 months at the max. And then whenever you say, okay, I want this current financial year, it will give you two options: either you download it, okay, or you email it, right? So there is something at the back end. We will also talk about this also in OLTP, how they do all these things. But at the moment, it was, when it was decided, it was like, okay, I'll give you the latest state of the data. Size is very not, I would say, very less, because data is prepared very at a very fast pace, but it is gigabytes to terabytes. Okay, not too much. Maybe big companies would be doing petabytes, but in compared to OLAP, it's totally different. Now if we see about OLAP, okay, you are doing aggregates, large number of records, bulk imports you are doing. Who is the user? Users are always business managers. Okay, they do something, they would be using it for something, uh, for decision support system. Okay, they are not meant actually for OLTP purposes, wherein people want to see, okay, what was my last 2 years of record or data. No, they don't want to do that. So this is historical, and everything is coming under OLAP. So this was a basic history of OLTP and transactional stuff, because transactions are the base of OLTP. Okay, so if there is a transaction, it means it is OLTP. If there is no transaction, it can be any other thing, but there is no such thing happening right now in the world without a transaction. Okay, so it has to be gone via transaction. So we come to a next topic which states like, what is the storage pattern of an OLTP? OLTP, if anyone would have worked on OLTP systems, they are hardly, so if I talk about relational only, they are all row based. Okay, they give some features on top of it which can improve their performance and make it columnar storage. Okay, maybe indexes, clustered indexes. But MySQL, Postgres, SQL Server, Oracle, their base feature is like, if you create a simple table or anything, it will be a row storage pattern. You can enhance it by doing a lot of stuff, and adding indexes or something. But yeah, basic it is row storage. What is row storage now? So I'll tell you by the example of this query. Okay, So in this query, if you see, right, there is one major thing part which I've highlighted. Rest all we know, right, what is happening. This join is on date key. We chose date key because if we have not chosen date key or product sk in this case, okay, this example is actually fetching the data, getting a sum of quantity sold on a particular date, which is year 2013, and the category was fruit or something. Okay, then it is grouping by. But to do that, it has to join one or two or three tables. Okay, so in a row storage, what happens is everything is stored as a row, complete row. Okay, there is no idea of columnar. Okay, so I'll not create a column here. Okay, so I'll not create that. So whenever it stores, it has to store as a row and it has to give an id to it. Okay, internally, even if you don't give an id, it is storing with an index. Sorry, not an index but internal ids. Okay, so this is stored here. Now, to make this efficient, right, because this would be having at least millions of record. Okay, maybe some places you might see a millions of record actually on oltp system, which is actually possible. Okay, but they want to fetch last year only. Okay, so to do that, it has to sort this. Okay, first, if you don't sort this internally, and if you don't keep it internally sorted somewhere, you will lag the query and you will face performance issues. So okay, it says okay, you create two keys, which is fine, which is one key is this. Okay, and another key is this because you are joining on this. Then the system says okay, I have joined on this, now get me the data. It says you have not created indexes on this. Okay, even if you are joining it, I don't know whether it is sorted or not. Okay, so you create index on this, it keeps, then it keeps full row with it. Okay, it keeps full row as a sorted. It's not even talking about the columns we are querying. Okay, the columns we are querying, it's not even talking about it. It's saying okay, since you are querying me and I am oltp, I don't know what are columns you are checking, I know the row. And now imagine there are hundreds of columns. The row size is going above, up and above by, let's say, 10 to 12 mbs. Okay, it's lots of data. Okay, then every time whenever an index fetches, it has to go back and fetch the full bytes of it. Again there is a pressure on the system and it gets slowed down. So another thing to understand is they are meant for efficient read and write at a low latency. Okay, so we cannot perform these types of queries. Okay, okay, efficiently. Okay, if you want efficient way, you mention last 6 months or 1 month or whatever, it will fetch it. But again, the number of columns, if they are huge, you will have to do another product engineering or you know design dimensional designing, wherein you have, if somebody is asking for some sort of reports, you give them at the moment, and which is already happening on oltp, which I'm saying it is not happening, but it is happening. But this is meant, this topic is meant to understand you this thing is that since this is row storage, we cannot use this for querying huge amount of data. So oltp systems are there. So in an interview, right, when people say that okay, I have to do an etl from oltp to an olap, you have to think from the perspective what they are saying. They are saying 6 months, 1 year, 10 years of data. You are hitting the system directly. You are killing the main system. Okay. Okay. They are asking this question because they want you to fall into the trap of answering that, okay, I'll do this query, which I already showed you. And then they will say this table, these all tables have millions of record. And then they will say it has index also. Then you will fall into the trap that okay, why would I do this? They will say wouldn't this lock everything on the OLTP? Because people are actually putting the data, okay, people are actually putting the data there, uh, entering the inserts record, everything is happening. But what will happen? Since you will fetch it, it will be a problem. And here I have mentioned dim date and fact sales date to make it more clear that it is a fact and a dim. But in an OLTP systems, they are not mentioned as dim date or something, okay. They will be mentioned as calendar, or sales dot date key, and it will be product, sales dot product sk or something, but query would be same. So when you fetch the data from OLTP to OLAP, you have to think all of this in mind. What I'm going to do if you say that, okay, I'll build a query and just fetch the data, whether it is Python or any ETL tool. Just think about it. What you are trying to answer? You are saying that I will be locking the system till the moment I don't get the data. Okay, I will be locking it. I will be putting a pressure on that. So we'll see that select statement also put a lock. It is not that only write puts a lock. Okay, so select statement also put a lock, which is not hampering anything, but you may read a dirty read if there is an already a lock on a table which is inserting the data into OLTP. So OLTP systems continuously get the records in, and you are continuously hitting the select queries on that. Because of this, the system is locked, and you are already maybe reading a bad record, or half cooked records, or half cooked data, or dirty reads, it is the actual terms which is said. So you may be not reading the correct data. So then you will say in an interview, okay, I'll do a batch load once a day, which will be my nightly job, which was at the night nothing happens. Then they will say, okay, my website is kind of an Amazon. Okay, the transaction happens throughout the day, even 24 hours. How will you do a 24-hour job on that? It will be logged, right? So do you guys understand what is the problem here? So OLTP systems are separate. ETLs are trying to kill it, okay, with the queries. They are already killed by the users who are putting the transactions on top of it. You are not getting the data to an OLAP. It's a problem, right? So there is a solution to this, which we will discuss very, not very late, but it's not part of this. But these are all solutions exist, okay. So we'll continue with the OLTP, but keep these things in mind, because interviewer will not leave you behind this. So they will ask such questions. Okay, what will happen if you are actually killing the OLTP system, and how to stop it? Now I'll talk about acid. Okay, when we say OLTPs, right? OLTPs cannot work without acid. Okay, and what is acid? So this is the first, I guess, question which was asked way back in my time. Why acid, and what all things acid means? Maybe you would have faced this or not. Anybody, if you want to take a hit on it, what is acid, and whether you are asked some time back or whenever you gave an interview? Hmm. Hmm. Okay. Isolation and durability. Mhm. So, Deepti, you want to take any hit on this? You are listening, right? I guess. Okay. So, anyone, Shashidhar or Deepti, you want to take a. Okay. But you know what is acid? You don't know. Okay. Shashidhar? Mm-hmm. 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 Hmm. Hmm. Okay. Okay. So before entering into this topic, right, I will ask you one thing, everyone. Okay. Do you expect Amazon to have only one Postgres or MySQL or Amazon RDS instance? No, right? This is blanket statement, right? They will not be having one RDS instance, 100%. They might be having maybe 10K or something load balancer in between what would be doing it. Transactions would be happening on all of them because it is a distributed system, which is another big topic, but I will have to introduce that topic here because to understand distributed systems, sorry, to understand acid, you first need to get an idea of distributed system. Otherwise this will not make sense because this will be a theory for you, and you will keep answering such questions wherein okay, the transaction happened and it was debited and it has to be credited to someone's account. It is a right answer for 2 years or 3 years of guy, but by 5 to 7 years, uh, with the current situation, they'll ask you more because you have an AI to read more on this. Okay, with an example. Earlier in uh, days before, you'd never get a right, example because nobody could think that much. Now, if you go and ask why we need acid to, chat GPT or Gemini, it will give you a fabulous answer. Okay. So distributed system. So let's say there are 10 instances of same RDS, okay, or Cloud SQL. There is one geography which is India. There is one geography which is Europe. One geography US. One geography, let's say uh, inside SAP Mina somewhere. Then every place there are instances, they are all connected. Okay, they are not left behind. If a transaction happens in India, it will go into the India server. Okay, and it will be replicated somewhere. If the transaction happens into US, it will be happened into US because it is closest to that, and it will be replicated somewhere in Europe or India, so to keep high availability. So all this happens, right, which means they are all connected. Now when I say atomicity, okay, then atomicity is okay, it happened on that system. Was it reflected at the same moment, replicated at the same moment in India when it was done in US? Because a person sitting in US, which is a manager, if he is seeing a report maybe from an OLTP system, okay, the latest reports, he has to see, right, the transaction has happened. Okay, the lag, okay, the lag will kill the atomicity. First thing is that, okay, if the transaction happened, it has to be replicated to all the systems, and it has, if it has been replicated, if it was properly committed, then atomicity comes into picture. It is not that only on one system. The point I'm trying to say is these systems are distributed. Okay, so never answer things from a perspective of one system. Okay, they are all connected. So whenever acid comes into picture, think about distributed systems, that okay, it was done on US, and then because of a network issue somebody fixed maybe a network lag, and their transaction could not happen. Okay, they went to the order cart, they clicked on place order. Okay, then OTP was sent, they were doing that, they entered a wrong OTP, everything has to roll back, right? Now since everything has to roll back, can you expect the actual transaction to be replicated into another system? Yes, it has to be rollback transaction coming in into India because they had to see, because that was a failure. Okay, they record that also. Everyone records their failures. So databases have to be atomic, which means one transaction is start of a group of statements. Maybe it is starting from selecting of the products, adding to cart, and then actually ordering it. So these all statement will create one transaction, and it has to complete. And if it has been completed and then replicated back to everywhere, then it is atomic. Okay, then I would say that it was atomic on US. No, it cannot be only atomic on US. It has to be atomic on every other replicated connected system. Okay. So with this, when I say every other replicated system, because it was consisted on US, consistency comes into picture, and it says okay, it has to be consistent across everywhere. Okay, the replication has to be so good that once they are connected, it replicates automatically within fraction of second, and consistency comes into picture here. Okay, so why acid? Application may crash, interruption in networks, read data that does not make sense. Okay, you could be reading partial. Last statement, I have not highlighted it, but that is the most important statement. Okay, but that would take you to another level. Okay, race conditions. So many people trying to do same transaction. Okay, so many people trying to do a same transaction on a same server on a same machine which is in US. It will face race conditions, which transaction to record first. Okay, at the same moment, within that fraction of second, we have seen that in Flipkart. Okay, Flipkart in earlier days used to crash. Okay, so race conditions happens when people try understand it from a term of race. Okay, race is like everyone wants to run fast. Okay, they want to win the race. So race condition do happens, and when all that clients try to enter into the same time the transactions, these will happen. Don't worry about this right now. This is a very uh, big topic on race conditions, but we'll discuss about this in replication when we talk about distributed systems. So why acid? Now atomicity, isolation and durability we'll talk, because but atomicity and consistency we have already talked about. So to keep the system reliable, okay, and these features ensure that they don't cause catastrophic failures. Okay, keep the system intact. They cannot make you unhappy. Okay, they have to make you happy buying things. They have to make you happy by posting your image. Okay, you are sharing it the moment you are posting an image, so they want you to see happy, and everybody wants happy customer. So that's why they have built it fault tolerance. Okay, fault tolerance is the term. But everything cannot be tested and fault be fault tolerant. Okay, something can be failed. Okay, so that's why acid is in place, that at least some stuff which is basic recording of a transaction is all atomic, consistent, isolated, and durable. Now when we talk about isolation and durability, we talk about transactions. Okay, so whenever you understand from the perspective of transactions, we already know that okay, whether it will be commit or fail, there is no uh, commit, abort, or rollback. So there is no in between state. Okay, either one or zero. That's it. Okay, we can't talk about 0 point something. It is very gray area. Oh, sorry, very dark, which is either white or black. Okay, so no gray area is there. If it fails, the application can safely retry because we have transactions. Okay, so retry mechanisms, when you see exception handling, you were able to do that exception handling because database systems eventually gave you a benefit or the power to roll back stuff. You just enter in a high level language rollback, and at the back end what the system does for you is magic, right? Because there was a failure, you never entered that or inserted or updated or deleted that record, because there was a failure. Because of that you could have done it, because without that you could have not done it, right? So this means transactions are really cool stuff, I would say. Always executed as one. If done, it is done. If it's not, it will be rolled back. So error handling becomes easier, and it's not to worry about partial failures. Okay. So whenever you start everything, even you can do every line as a transaction. People entered a website, a transaction was created, committed. That's it. He or she was successfully landed to a home page. Transaction recorded. That's it. Something done, something else done. So these all things are recorded, and these are nothing else apart from these as logs. Okay, transactions are all logs. In actual terminology, when we see replication, distributed system, when we talk about that, these are all logs. and it all has a transaction ID which has to be, common across all the replicated systems. So this is what it is. Transactions are nothing but logs. Okay. So logs of you started correct, you ended correct. So if you are new to OLTP systems, you might have not read about this thing, which is lock and control and lock mechanism. Okay, what is this thing? Any idea? What is control and lock mechanism? Row level security comes into OLAP, but you have actually tried to understand the main thought that there is a lock somewhere, and it is when we are talking about OLTP, it is only on the row level. So uh, hmm, hmm, yeah. So you are partially right when it is an exclusive lock, which is a write lock. Okay, but shared locks are different, so you can still read something if it is not locked. So I'll tell you one thing: if you don't have anything right now, how to try this? You try this maybe on any BigQuery or something. Okay, I'm not sure if it will be there, but all systems, MySQL, Postgres, any RDBMS, you can try this. You open one script and start writing insert into a table. You do a big and tran before that, okay? And into a next session, you go and start to read that table. It will not be reading until and unless you have inserted even a single row. I'm just saying a single row, okay? Until and unless you commit that transaction, because it has applied an exclusive lock, because you are inserting, you are doing a write lock on that. So what write lock does is it allows the transaction to update, delete, or insert. Okay, only one transaction at a moment. And why we are talking about locking is because you need to understand, when I was telling that people are hitting your OLTP systems, they are actually locking it. Okay, they are locking their transactions, they are locking their rows. Okay, they don't know it, but system knows it, that somebody is locking their particular uh, order ID, product ID, payments, everything they are locking. You cannot read it until unless it is completed. So until and unless the transaction completes, you cannot read it. So what problems can happen without concurrency control? Now concurrency control comes into the topic, wherein concurrency control is so many people are doing concurrent transactions on your website. Okay, if you are going to read this via ETL, three problems can happen. Either you will read a dirty read, you will read a non-repeatable reads, you will read a phantom read. You don't know to know all this in detail, but dirty read, right? Something has not happened, but you are still reading it. Okay, okay. Non-repeatable means reading the same row twice. Okay, you are reading the same row twice, which is duplicacy. Phantom reads executing a query and seeing new phantom rows. Okay, which is when you first run it, you said you saw that okay, two rows were there. Now when you run it, you see there are six rows for that user ID, because inserts are continuously happening, right? And you will see that. So database developers, I would not say database developers, I would say the people who built the RDBMS system, they were not fool. So they actually built isolation mechanism on top of this. So they said that okay, we give you the liberty, it's all dependent on you, whether you want to read dirty reads, you want to read exact serializable committed reads, or you want to read committed repeat. So there are four isolation level, we'll see that. So dirty reads are allowed, then read repeatables is allowed, then totally committed are allowed. So y- as a user we can tell the system, okay, I need only all the committed reads. Okay. If you want that, then which means you will have to wait until unless this completes. If you say that I'm okay with the dirty reads, let it come, okay, then you will not lock the system. Okay. There your read locks will be not locked by the write lock. Okay. Because the write lock has locked the row and you are saying that I want to read dirty reads because of the isolation level, you can give that isolation level in your query. You will say okay, I'm okay, I'll read the dirty reads, which is okay. So but it is so critical that you cannot show dirty reads. You will say I want to read committed. Okay, I want to only read the committed rows. Then it will say okay, wait till the moment I commit this transaction. So until and unless I commit this transaction, you cannot read it. So this was the whole understanding to understand isolation. Okay, so control and lock mechanism comes into picture when we talk about isolation, because isolation is you and me are isolated. You are sitting at your place, I am sitting at my place. My belonging surroundings are isolated from you. Okay, you are not even, so I am not locking your machine right now. Okay, I'm not locking your water bottle. If you want, you can drink the water from your water bottle. Okay, if we are going to share the same stuff, if we are sleeping on the sorry, if we are staying in the same room, and if we want to consume the same stuff, then probably we might lock sometime. Okay, you want to use that laptop or PlayStation, then you are putting your own maybe hours before it, that at this moment I'll play, it's my lock on that. Okay, nobody's going to disturb me. So this is where locks comes into picture. So you don't need to deep dive into this, but you need to understand whenever people try to say fetch the data from OLTP via ETL, you need to understand, you'll have to ask, is there a transaction happening? What is the free time? At what time your website is free? They'll say no, it is never free, 24 hours. You don't have that mechanism, right? You have to have another instance which is a read replica. From that you can read it. So that's the depth they want to ask. Okay, if you keep locking the same system, you are hampering the performance of the end user, because you only need to create reports. You cannot hamper the system. You have to create a replica which will just read the data and not log anything. Okay, so when we talk about distributed system, we'll talk about replicas, and then if you will be able to recall it from cloud SQL perspective where there are replicas we can create. So log granularity, again, I told that it is on row level only, but it is actually available on page, which is page is a group of rows, as in a block of memory which is 8 KB or 4 KB sometimes. A table level lock, okay, you can lock a full table. This is the beauty of database systems. You can do that. A database level lock, you can lock the full database. Okay, complete lock. Nobody can use any table. Okay, whenever you try to hit it, it will give you a timeout error. So this is all that happens. So atomicity we have already discussed. Okay, and it is not about concurrency, that I have already told you. Okay, it has to be, if the transaction is done, it is done. Concurrency comes into picture when more than one people do, then you know uh, we'll say that okay, it is concurrent. So atomicity is, uh, in general reference, as we know, something that can be broken down into smaller parts and then can be committed, whether it is a transaction or uh, rollback. Sorry, commit or a rollback. Atomicity describes what happens if the client wants to make several writes, but fault occurs after some writes, so you can roll back. Okay, so if writes are grouped together and inserted into a database, it will be write committed, and if you are rollbacking it and aborted, two more options are there. You can abort it or you can roll back it. So you can do that also. So this was about atomicity. Atomicity we have already discussed. Consistency is what we are talking about here. Okay, so the idea of consistency I already told you, right? consistency is one thing which database cannot guarantee. Okay, if you write a code wherein you are debiting but you are not crediting to someone, it's your problem, right? It is not consistent. Okay, the data is not consistent and you are just debited and not credited somewhere. So application code depends here. Okay, so consistency, when we talk about distributed systems, it will be more understandable from that perspective, that consistency means that across the network, whichever instances you have, your stuff should be consistent. Okay, the idea of consistency depends on application notion of invariants. Invariants means which has to always be true. Okay, debit then credit. Okay, so consistency we'll talk in detail when we talk about distributed systems, or even if you answer anything, think in mind that consistency has to be related to application code. Okay, more of an application code and the replicated systems. Isolation I already told you, and there are four levels, four types of isolation, and they are here: read committed, read repeatable, read serializable, sorry, repeatable read, serializable, and snapshot. Uncommitted means you are reading dirty reads. Committed means you are waiting till the lock is removed. Repeatable reads means you are allowing the same transactions to be repeated every, like first you saw a user ID inserted, again you are seeing that user ID inserted again and again and again. Serializable is 100% consistent, which means consistent as in 100% true, that you are not even seeing a single, it is very close to read committed. Okay, but you are seeing a serialized way, like the order is consistent. Okay, if you entered row ID as in insert ID of Navneet first and then Deepthi, then serializable will make sure that that happens, that okay, uh, then it was Navneet's transaction, then it was Deepti's transaction, but read committed will not make sure that. Okay, and snapshot, it will just give you a snapshot of it. So snapshot by the basic meaning of it. Durability, uh, we all know that these systems are actually file based. Okay, file based as in binary. So it converts the data into bytes and store into some .db files. Okay, in some other tables it would be some other, sorry, in some other database engine it could be some other type of file, but probably I guess in every system it is .db file. Okay, SQL servers, I know, so they create the file. Okay, so every database has one file, so it will be created. How many database you have, so for all databases you will have a db file. So once the transaction are committed successfully, and any data, okay, cannot be forgotten, it is persisted, it cannot be forgotten. So once you do that, because in RAM this never happens. Okay, there are other available systems wherein you can do, but then it will forget. Okay, because it has to be fast, very fast. RAM is faster than storage. So when you store the data in .db file, it is committed, then it has to be not forgotten. Anything happen, even the crash happens. Okay, until and unless your disk got corrupted. Okay, hardware faults are okay, your network connectivity is okay, but until and unless database, sorry, not your disk crashes, disk is corrupted, your data is saved. That is durability. Okay, and in replicated databases, durability may mean that data has been successfully copied across some number of nodes. So always there will be replication in picture. Okay, because now we are into a stage where we have to answer acid from a perspective of distributed systems, not one system. Okay, so in order to provide a durability guarantee, a database must wait until these writes are replicated are complete, replications are complete. Okay, so it has to wait until all the systems which are connected have got the replication successful, and to report that okay, that transaction has been successfully committed. This is durability. So the one which was already talking to you about in atomicity, that it has committed in US but it has not replicated in India, which means it is still missing something. Okay, it is still missing something, and it is missing that consistency and durability. Concurrent durability, not consistency. So concurrent durability is the term. So everywhere it should be replicated. But we all know that there is no perfect durability, because anything can happen. As I told, your disk can crash, okay, and backups can be destroyed, and anything that happens, which means you are not prepared for the disaster. So we also know that there is no one guarantee, right? No one can guarantee that anything can be successful. But yeah, your systems are built this way that once you write to a disk, it will always be safe, and then you can replicate it to somewhere, and then take backups. So disaster recovery is possible. It's not 100% true that, okay, if it went down in US, it will also went down in India, which is rare chance. Okay, if it went down in India, it will not went down in Europe. So they keep replicating the transaction everywhere. So with this topic, I'll stop here. So next topic is normalization, which I'll cover in the next session, and I'll stop the recording now.